In the harshest, most unforgiving place on Earth, human life hangs by a thread. This is Antarctica, a continent of ice where temperatures plummet to bone-chilling extremes. At minus 60 degrees Celsius, steel becomes brittle as glass. Diesel fuel turns to gel. Hydraulic fluid freezes solid. For the scientists and explorers at the South Pole, survival depends not on their courage alone, but on a lifeline, a machine built to defy the impossible. This is the story of that machine, a mechanical beast engineered to conquer the cold when all others fail. When a standard tractor faces the Antarctic winter, it's a death sentence. Within minutes, its metal components contract and fracture. Its engine seizes. It becomes a frozen monument, useless. So, how do you build a vehicle that can not only survive but thrive in an environment that actively tries to destroy it? You don't just modify an existing machine, you rethink it from the ground up. This is where human ingenuity meets nature's most brutal challenge. Meet the Traverse, Antarctica's unsung hero. On the outside, it might resemble a heavy-duty tractor, but beneath its skin lies a marvel of polar engineering. The first problem is the cold's attack on metal. Standard steel is like a tightly packed formation of soldiers. When extreme cold hits, that formation shatters. The Traverse, however, is built with a specialized low-temperature alloy. Imagine those soldiers are now holding hands, creating a flexible, resilient chain. This steel can contract in the cold without cracking, giving the machine its structural integrity. But the frame is just the beginning. The real battle is internal. Think of the machine's fluids as its bloodstream. In a normal vehicle at minus 60, this blood turns to sludge. The Traverse uses a custom-formulated synthetic hydraulic fluid. It's like replacing water with a special antifreeze that refuses to solidify, even when the air itself feels like frozen needles. This allows the massive hydraulic arms and plows to move with precision, clearing life-saving paths through house-sized snowdrifts. What about the engine? A standard diesel engine wouldn't even start. The fuel would be a waxy solid. The Traverse employs a multi-stage heating system. Before the engine even attempts to turn over, a web of electric heaters gently warms the engine block, the oil pan, and the fuel lines. It's like slowly waking a hibernating bear, rather than shocking it into action. Once running, the engine's own massive heat is captured and reputed, creating a self-sustaining warm bubble in the heart of the frozen beast. It actively fights the cold from the inside out. The tracks are another masterpiece. Instead of typical steel treads that would offer zero grip on sheer ice, the Traverse uses wide rubberized tracks embedded with carbide steel studs. Imagine the difference between wearing dress shoes and professional climbing crampons on a glacier. This design distributes the machine's immense weight, preventing it from sinking into the snow, while the studs bite into the ice, providing relentless traction. It can climb slopes of solid ice that would be impossible for any other vehicle its size. Inside the cabin, it's another world. The operator is shielded by triple-pane vacuum-sealed glass. It's the same principle as a high-tech thermos. This insulates the interior so effectively that a simple heating unit can maintain a comfortable room temperature, even as an apocalyptic blizzard rages just inches away. The controls are not the typical cold, hard levers. They are oversized and designed to be used with thick, clumsy mittens, because in Antarctica, exposed skin is a medical emergency. Every year, these machines perform the South Pole Traverse, a perilous 1,000-mile journey over the polar plateau. They haul tens of thousands of pounds of fuel, food, and scientific equipment to the Amundsen Scott South Pole Station. This isn't a simple road trip. It's a high-stakes logistical ballet across a landscape of hidden crevasses and sastrugi wave-like ridges of hard snow that can shatter suspensions without these beasts of burden. The vital scientific research at the pole research that helps us understand our planet's climate would grind to a halt. These machines are more than just metal, wires, and fuel. They are a testament to our species' relentless drive to explore and understand. In the face of nature's most absolute and indifferent power, we did not retreat. We observed, we learned, and we engineered a solution. Thank you for watching. If you found this journey into extreme engineering fascinating, be sure to like this video.